Hello students, good evening everyone. Welcome to the session and welcome to the India's most comprehensive preparation platform, the BYJU'S Exam Prep. Yes guys, very good evening everyone. Right, so the EMFT part number 2, the session is live, and yes, this session of EMFT is again going to be common for both the electronics and electrical. So in the yesterday session, we could discuss mostly about the electrostatics part, right, including the capacitors and all. And we are yet to start with the magnetostatics, right? So because of the MSQ class coming up yesterday, power systems, so as demanded by many of the students, I had to stop before completing the magnetostat. So that is why today we will dedicate this session to magnetostatics, boundary conditions, and etc. No, admit card not as of now. Let me just, because I just keep checking, not as of now. Yes. Okay. Okay. Yesterday I didn't give the password. Password will be given today because yesterday's and today's PDF will be combined with a common password. Okay, combined PDF hoga. So chalo guys, let us get started. As I'm telling you that we are going to mostly discuss about the magnetostatics and boundary conditions. That is again common for the EC and EE. Okay, chalo. Okay, so this is a brief intro about me in case if somebody joining new to the session. This is Rakesh. I have secured All India rank 9th in the GATE examination and completed my masters from the Indian Institute of Science, Bangalore. Right. Yeah, today we will cover the common portion. Today we will cover the common portion of ECEE. Finish kar lenge isko. Right, let us move on. As you know, the GATE Maha Marathon is live. It is going on across all the branches. Okay, we started from 2nd or 3rd of January and non-stop from past 10 days around. We have been giving you the complete revision. Okay, the complete revision. Yes guys, all the PDFs we have shared to you except digital part 2. There was some technical issue in retrieving it. Okay, still the team is working on it. If we are able to successfully retrieve the digital part 2, we'll share you as soon as possible as we get it. Okay. Don't worry about it. Rest all the PDFs were shared to you. Yes guys, and as I told you, lots of the sessions are going to come up on this channel, whether it is regarding the GATE or regarding the ESE. So let me give you a quick update now. You know, yesterday I was telling you coming soon, and now today I am here with the date coming up. Okay, so now here we are coming up with the date. So yes guys, those who want the entire revision of general aptitude, including the verbal part. Okay, 15 marks in 15 hours, not 51 of course. If you really want to get the benefit, and if you really want, agar abhi bhi kuch nahi kiya aptitude mein and you want to grab these 15 marks, okay, let's have a 15 marks scoring in 15 hours of marathon session. Okay, with general aptitude. Maths will be coming up after this. Maths ka bhi main update karunga, but this is all about general aptitude, and this is going to be live from the 16th of January. This is going to be live from 16th of January for 3 days, right? It is a 3 days event at 5 hours marathon daily, 5 hours non-stop marathon daily, right? Okay, live from 16 January on the same channel where you are watching this session. So do keep on subscribing, and not only this guys, several other sessions. Okay, we are going to bring you some general talks regarding the GATE 22 examination, virtual calculator, scribble pad, GATE interface ko use kaise karte hain, how to manage your time. Okay, what do the GATE 21 toppers say about the GATE 22 preparation? That also we are going to bring up very soon. So lots of activities coming up. Do not forget to subscribe if you haven't subscribed, so that you don't miss any of these sessions. Okay, and keep on going with your effective preparation, sahi preparation, right? Chalo, all cool guys. Okay, so let us get started guys. So we were just about to start the Biot-Savart law, but we just could not. Maybe time I don't know, but tentatively 11 or 12. I'll confirm you tomorrow. I will be there in the telegram also, but aptitude marathon time will be most likely 11 or 12, say 12 around, we can say. Okay, exact time and all I'll confirm you. Okay, don't worry about that. Chalo. So guys, Biot-Savart law, let's start here. We will do that. See, I don't know whether the exam is going to be postponed or not, unless and until IIT Kharagpur. There are, rumors of both the types. So there is no official confirmation by IIT Kharagpur. So you should not think about this right now. Right now, you should only think that exam is going to happen on time, so that you prepare with the full heart. Okay, full effort should be given. Okay. Biot-Savart law, which states that the differential magnetic field. See, actually, results of Biot-Savart law will be more important. Okay, results of Biot-Savart law will be more important. But yeah, let's go through the basic element also. The differential magnetic field intensity produced at point P by some differential current element. So see, suppose this is some differential current element. What do you mean by the differential current element? A small current element. Okay, a current element with some small length dl. Okay, with small length dl. Right. Okay, guys, those are not official updates. Okay, see. If there are some rumors going on in some of the papers today, in some of the news, that is not official. Okay, that is not official. If anything is official, that will be put on the IIT Kharagpur website. So guys, you guys are grown up, okay, and intelligent enough to handle what is rumor and what is truth. What is truth should be on the IIT Kharagpur website, and there is nothing on IIT Kharagpur website after 7th of January. Okay. Right. Okay. Chalo. Let's keep on going, guys. So, we are unnecessarily having other discussion, guys. Now, let us be specific to the topic. I am not going to handle any more general queries right now. Otherwise, I am not able to start my content for today. Okay. So, a small current element having some small length dl, the magnetic field, the differential magnetic field produced at any point P, okay, according to the Biot-Savart law, is proportional to the product IDL and the sine of the angle alpha. Okay, the sine of the angle alpha between what? Between the current element and the line joining the current element to the point of observation. So basically, from the current element to the point of observation, एक line बनाएंगे. What is the angle between this line and the current element? That is known as the alpha. That is basically known as the alpha. Okay, so DH is proportional to IDL, it is also proportional to sine alpha, hence it is proportional to ideal sine alpha, and then it is inversely proportional to the square of the distance between them, just like the Coulomb's law as well. So that is 1 upon r square. Okay, DH is also proportional to 1 upon r square. Okay, final form, DH is K ideal sine alpha upon r square, where K is the constant of proportionality. In the SI units, it is equal to 1 upon 4 pi, right? Chalo. Okay, in the final vector form, because the sine alpha is involved, because of the involvement of sine alpha, we can convert this formula into the cross product, because we know sine alpha comes in the cross product formula. A cross B is AB sine alpha AN cap, right? So it can be further written as ideal cross AR upon 4 pi r square. Okay, don't worry, very less chance that this is going to be directly useful to you. You must just know Biot-Savart law, but how do you derive the field? I'll give you the direct formula. And what are the questions that we are going to expect on the application of Biot-Savart law? Us pe aa jate. Because this is a revision session, let's not go into derivation and theory much. Formulas and questions and application oriented detailed concepts, ये सब discuss करते हैं यहाँ पे. Acha. Then, because the cross product is involved, how can you calculate? Because the cross product is involved, how can you calculate the direction of the magnetic field? To calculate the direction of magnetic field, we'll simply use the right hand thumb rule. How we use the right hand thumb rule? Suppose this is the line current. Suppose this is the line carrying the current I. Suppose this is the line with some small length dl carrying the current I. Okay. Suppose the current I is flowing in the upwards direction, vertical direction. How do you calculate the magnetic field direction, sir? Take the right hand thumb rule. क्या करेंगे right hand thumb rule में? Place the thumb of your right hand along the direction of the current. Okay, along the direction of current and rotate. This is important because there can be some direction based 1 marker logical question from this topic. Place the thumb of the right hand along the direction of the current, rotate your fingers, curl your fingers. Okay, the curling of the fingers, okay, the rotation of the fingers will tell you the direction of magnetic field. Now, let's suppose this example. This is the direction of current. I point my thumb in the direction of current and I see what is the direction in which my fingers will come. Okay, what is the direction in which my fingers will curl? Okay, that direction is the direction of the magnetic field actually. That direction is the direction of the magnetic field. This is also given by the right hand screw rule. This is also given by the right hand screw rule. According to the right hand screw rule, क्या करना है? Take a screw, okay, and try to fasten up the screw. Screw को tight करते हैं ना, कसते हैं ना. Okay, try to fasten up the screw in the direction of current. So current is flowing upwards. So imagine that you are, tightening a screw, okay, upwards in the direction of current. Okay, the direction of the tip, okay, the direction of the circular tip of the screw will tell the direction of magnetic field. जिस direction में ये घूम रहा है ना, in which direction it is rotating? It is rotating in this circular direction. Okay, now let us be simple. If I imagine, everybody can tell me, na, if I imagine that this is the z-axis, let us suppose the current is in z-axis. Let's suppose the current is in z-axis. Okay, then what is the direction of magnetic field? According to the right hand thumb rule or screw rule, anyone if you take, according to them, the direction of magnetic field is in a circular direction, once again everybody, is in a circular direction about the z-axis. What is the circular direction about z-axis known as? First you guys comment and then I will let you know. What is the circular direction about the z-axis known as? Everybody, I am looking for your comments, right? As always, as expected, from day 1 to day 2, whatever the subject may be, whatever the case may be, from day 1 to day 2, always attendance thoda niche hota jata hai. Okay, that's the mentality. Those who are live, they are maybe towards the mentality of toppers, and those who were live yesterday but not live today, they are just those who will always leave the examination, who will always leave the preparation than the last. So jo log live hai, they must always be proud of themselves that they are really putting up the efforts each and every day. Okay, yes, basically correct. The circular direction about the z-axis is known as the azimuthal direction. Cartesian, cylindrical coordinate system को ध्यान रखेंगे. So this is known as the a phi direction, azimuthal direction. Okay. So if the current flows in the z direction, then I can say that the magnetic field is in the azimuthal direction. I will tell you one more simple way of finding the direction. One is the right hand thumb rule or screw rule, and one is the formula of direction. That also I will discuss with you. Now, one of the important results coming up from the Biot-Savart law, very important formula. Okay, very important formula is that you have a straight current carrying filamentary conductor. Now, what is a filamentary conductor? What is a filamentary conductor? Filament is something which is very thin. Okay, so basically a very thin conductor of negligible diameter, just like a very thin wire, you can say, a very thin piece of wire carrying some current I, and that should have the finite length. Acha. Okay, try to understand this. Okay. Where is this filamentary conductor? Sir, this is the filamentary conductor. Very thin conductor which is placed from A to B. It is carrying the current, okay, from A to the B. Okay, in the direction from A to the B. Yeah, you can just imagine from the filament of bulb also, Shubham. Chalo, bahut badhiya, right? Now, if this is a filamentary conductor, a very thin conductor carrying some current I, okay, carrying some current I from A to B, what is the magnetic field produced at any point P in the space? At any point P in the space, it is given by the formula, direct formula. This is derived using Biot-Savart, but abhi derive karne ka time nahi hai. I divided by the 4 pi rho cos of alpha 2 minus cos of alpha 1. I divided by 4 pi rho cos of alpha 2 minus cos of alpha 1 a phi. A phi, as I explained, you see here, the direction of current here has been assumed as z-axis. So that is why if the current is in z-axis, the magnetic field is along the azimuthal direction, phi direction. But I told you one more method of direction, I will explain you. Okay. But sir, what are these terms alpha 2, alpha 1, rho, I? Let us be little simple. इसको एकदम simple way से मैं explain करता हूँ. Everybody, just please follow. Okay. Let me make this current element once again here. Let me make this. This is the starting point. This is the ending point of the current. The current is flowing in the upwards direction. That is from A to B. Okay, this is the current I. Okay, this is some point of observation where I am needed to calculate the magnetic field. Dhyan dena. To find out the magnetic field at any point P, number one, join the point P with respect to both the ends. With respect to both the ends of the wire. That means from A and B. Join it with respect to both the ends A and B. Okay. Also join a perpendicular from the axis of the wire from the axis of the wire to the point of observation. Now, if this is my wire, this is very important concept. If this is my wire, can I draw the perpendicular to the point P? If I go perpendicular, I will never be able to reach P. So, क्या करेंगे? We will extend the axis. मैंने क्या बोला? Find the perpendicular from the axis of the wire. Not necessarily from the wire, but from the axis of the wire. So, okay, so we will extend the axis of the wire downwards. इसको थोड़ा सा ना नीचे extend करेंगे. Then let us draw the perpendicular from P to the axis of the wire. Okay, let us draw the perpendicular from the P to the axis of the wire. Okay, this particular distance is known as the rho. This particular distance is known as the rho. Perpendicular distance from the axis of the wire. As I told you, what is the magnetic field? It is given by the formula I divided by the 4 pi rho cos of alpha 2 minus cos of alpha 1 a phi. Important formula hai, and this is the magnetic field, so its unit is ampere per meter. Rho is the perpendicular distance of P from the axis of the wire, number 1. I is the current flowing in the wire, that is simple. What is alpha 1, alpha 2? Sir, alpha 1 is known as the angle with the starting end of the current. But which angle? It is measured as exterior angle. देखो ये बाहर वाला angle है. If you are able to see in the previous picture also, this one is exterior, alpha 2 is interior. Okay, alpha 2, here it is the alpha 2. So let me mention both of them. Let me mention both of these values here. Okay, ये तो formula हो गया. Sir, what is the alpha 1 and alpha 2? Alpha 1 interior, sorry, alpha 1 exterior. Alpha 1 is known as the exterior angle with respect to starting end. Guys, I will take all the questions, but let us complete some formula and theory part. Okay, let us revise some formula and theory, then we are going to take the questions all together. Alpha 1 is the exterior angle with respect to the starting end of the wire. What is the alpha 2? Alpha 2 is the interior angle. ये interior angle है. It is known as the interior angle with respect to what? With respect to the terminating end, ending end. जहां पे current end हो रहा है, with respect to that point, interior angle is known as the alpha 2. This is what is alpha 1 and alpha 2. Rho also I explained you. Now how to calculate a phi? Direction I am telling you, there is one more method of calculating the direction. What is the direction? A phi. A phi can also be calculated as, there are two methods of calculating a phi. Number 1 is right hand thumb rule, already I told you. Number 1 is the right hand thumb rule, and number 2 is using the formula AL cross A rho. What is a phi? AL cross A rho. Right. Now what is AL and what is A rho? First of all, what is A rho? A rho is the direction of this perpendicular line जो यहाँ पे बनाया है ना. Okay, this is A rho. Unit vector along this perpendicular line, perpendicular from the axis of the wire to the point of observation. This is the direction A rho. Okay, what is AL? What is the AL? Okay, AL is the direction of the current. Okay, so AL is the direction. ये A rho यहाँ पे explain कर दिया. And what is the AL? AL is the direction of current flow. The direction in which the current is flowing, the direction of the line current element. ठीक है? That is what is known as the AL. Okay, so that is what is once again written here, AL cross A rho. Same thing has been explained here. AR is a unit vector along the line current and A rho is a unit vector along the perpendicular line from the line to the field point. Okay, everybody, that is what I told you. Expression is generally applicable for any straight filamentary conductor of finite length. Okay, it must be straight. It is not necessary that it should lie on the z-axis. For reference, we took z-axis, but it is not lying on z-axis always. It need not be on the z-axis, but it must be straight. Bas itna condition hai, it must be straight. Okay. Magnetic field is always along the concentric circular paths. Number 2. Now this is again very, very important. When the conductor is infinite in length, suppose I take a conductor which is very long. See, since yesterday I am telling, nothing is like infinity. Infinity means infinity means a conductor which is very large in length as compared to the distance of point of observation. Okay, so a long conductor, we also call it as, we also in the questions you will also see this being named as a long conductor. What? A long conductor. Okay, so when you take a long conductor, alpha 1, alpha 2, 180 or 0 aa jayega. No need to bother that, no need to derive here. Final formula, this is very important. I upon 2 pi rho a phi. So if it is a very long conductor, a conductor of infinite length, after putting the alpha 1, alpha 2 value, you are going to get the formula I divided by 2 pi rho a phi. इस पे directly, indirectly वेरी इंपॉर्टेंट फॉर्मूला, डायरेक्टली इनडायरेक्टली वेरी इंपॉर्टेंट फॉर्मूला. ठीक है, तो क्या करेंगे, एज आई एम टेलिंग यू, लेट अस वेट फॉर द क्वेश्चंस फॉर फ्यू मिनट्स. Okay, let us complete some more concepts and formulas all together, and then we'll go for the questions all together. Next, okay, now we took first, what is the first application from the Biot-Savart law we took is a filamentary conductor, a straight filamentary conductor, which may not be always on z axis, it can be on any axis, but it should be straight. Okay, what is the magnetic field due to a straight current carrying conductor? Next, if there is again a thin conductor, filamentary conductor, but that is in the form of wire, in the form of circular wire, circular loop. So if there is a circular loop in the xy plane, not necessarily xy plane, ये x है, okay, but there is a circular loop lying in any plane carrying this current I in the anti-clockwise direction, okay. What is the magnetic field at any point along the z-axis? The magnetic field is given by I rho square upon 2 rho square plus h square की power 3 by 2, where h means this coordinate 0 0 h. Okay, 0 0 h. इसमें भी देखो, there are very less chances of this one. What is more important I am highlighting, previous one is actually very important, either a finite length conductor or a infinite length conductor, straight conductor, very important. Circular conductor very less important. But इसमें अगर कुछ पूछेंगे भी ना, तो there is a special possibility that they may ask, what is the magnetic field exactly at the center of the loop? What is the magnetic field exactly at the center of the loop? So at the center of the loop means this point. I am referring to this point. So this point is 0 0 0. At this point 0 0 0, तो h का value 0 होगा, right? H का value 0 होगा, small h is 0. So what is the formula for the magnetic field going to be? I rho square, and denominator will be 2 rho cube. So it is simply I divided by 2 rho a n cap. I divided by the 2 rho a n cap. Sir, what is rho? Rho here is the radius. What is rho here? Here rho is known as the radius of the loop. Radius of the loop. This is the rho here. Radius of the loop. What is a n cap? What is the a n cap? A n cap is a unit vector. Unit vector normal to the plane of the loop, the plane in which loop is there, right? So यहाँ पे जो loop है, that is in the xy plane. If I talk with respect to this picture, here the loop is in the previous picture, the loop is in the xy plane, right? So what is a n cap? What is a vector which is normal to the xy plane? Normal to the xy plane is az. Is az. AKG, simple answer is only practice. GATE is not the exam where you just need to mug up. You need to practice some questions and the formula is set into the mind, right? That's what I believe. Okay. Okay, chalo, all cool. Okay, next one. Now Ampere circuital law. I'm telling you, let us revise the points. Okay, then finally we will take the question. Ampere circuital law, which states that the line integral of H, circulation of H around a closed path is same as the net current enclosed by that path. Little bit analogous, little bit similar to the Gauss law. Gauss law में हम लोग क्या बात करते थे? The flux. Yesterday we revised the Gauss law. The flux crossing any closed surface is equal to the charge enclosed by that surface. Here, the line integral of field around a closed path is equal to the current enclosed by that path. That means integral h dot dl, closed path ke around, okay, is equal to the current enclosed by this. Okay, this is also known as the Maxwell's, one of the Maxwell's equation for static field. One of the Maxwell's equation for static field. Static fields, time varying fields का भी मैं बता दूंगा आगे. Okay, so इस पे because it is a line integral along a closed path, and whenever you want to simplify the line integral along the closed path, we apply the Stokes theorem. तो यहाँ पे Stokes theorem लिखेंगे, and here we apply the Stokes theorem, and current is calculated as the surface integral of current density. J is known as the current density. Then equating both, we get the final result. केवल result पे focus करेंगे, forget all the derivation. Okay, let us focus only on the result. Del cross H equal to J. One possible area of question. Given the magnetic field, find the current density. Given the magnetic field, find the current density. What is this J? What is this J? J is known as the current density. Basically the conduction current density in ampere per square meter. Right. So this is one possible question producing area. Given the magnetic field, find the current density associated. Okay, so J is equal to del cross H. Okay, so del cross H equal to J is known as the differential form of Maxwell equation, and integral H dot dl equal to I enclosed is known as the integral form of Maxwell equation. Which Maxwell equation? यहाँ पे जो Maxwell equation को refer किया गया है, that is the Maxwell equation for static field once again. Time varying के लिए it changes little bit. Okay. Okay. So one more Maxwell's equation is there. Okay, we will summarize all Maxwell's equation in the last. Once for static fields, once for the time varying fields, right? Acha. Next is magnetic energy. Like the electrostatic energy density, what was the electrostatic energy density? Half epsilon E square, right? Yesterday we revised. Similarly, we have the magnetostatic energy density, half mu H square. Not very important, but just you should know the formula. Okay, the magnetostatic energy density, half mu H square. That's it. Okay, half mu H square. Okay, this concept's not directly useful, but little bit useful with the pointing vector when we talk about the power of the EM waves. Acha. Now, infinite line current. Okay, acha. Already we have discussed this. I'm just trying to mention here कि the magnetic field due to infinite line current. मैंने पहले Biot-Savart से show किया, but this can be also easily found using the application of Ampere's law. Already we know this formula. No need to discuss again. I upon 2 pi rho A phi. Okay. So infinite line current, again long wire carrying some current I. Already revised. इसको छोड़ देते हैं. Okay. Infinite sheet of current. Okay. If there is a entire sheet. Okay, if there is an entire sheet, let's say like this is finite. Okay, this is a finite sheet, but there's a infinite once again means some very large sheet. Nothing is like infinity, but some very, very large sheet, and that carries some current with the current density K. Okay, that current may be in any direction. Okay, suppose here in this picture, the current is shown in which direction? Y direction, but it could be in any direction. So consider a infinite means a very long sheet of current density K. Okay, current density K in ampere per meter. Okay, the current per meter of the sheet is given to you. Magnetic field is given by half K cross AN. I can say this topic, this particular formula, moderate important. Not less important also, but not very important also. Okay, but moderately important, I can say. Half K cross AN cap. It is known as the half K cross AN cap. K is the current density per meter, and AN cap. What is the AN cap? ये मैं mention कर देता हूँ यहाँ पे. AN cap. Question सभी पे करेंगे. Don't worry. Unit vector. Normal to the sheet, normal to the sheet of current, normal to the sheet, and of course towards the point of observation, because the point of observation may be above the sheet, may be below the sheet. Accordingly, okay, the AN cap may be plus Z here, or it may be minus Z, it depends. So unit vector normal to the sheet and towards the point of observation, towards the point of observation. Okay ji. Next, just like electric flux density we discussed yesterday, we have the magnetic flux density, so we can quickly relate and recall the formula. Just like D is equal to epsilon E, we have B is equal to mu into H. Right? For free space it is mu naught into H. If it is not the free space, okay, for other materials we write B is equal to mu H, where mu is equal to mu R into mu naught. That also we know. Right? The value of mu naught is known to everybody, that is 4 pi into 10 power minus 7 Henry per meter. Okay. Acha. What if I change the position of cross? Then will the answer vary? Position of which cross, Manish? In which sense you want to represent? Please, can you repeat again? If you change the position of cross, which cross, Manish? एक बार please mention कर देना. Who is this pedder? Okay, just please mention me once. Okay, now if I know the magnetic flux density, I can also calculate magnetic flux. Okay, just like electric flux, we call the magnetic flux as Xi only, and that is given by the integral of the flux density. Integral of the flux density. Now, flux is measured in the unit of Webers. Okay, so if flux is measured in the unit of Webers, there is one more unit, usko bhi hum discuss karenge abhi. Flux is measured in the unit of Webers, so this should be what? Surface integrating B will give you Xi. Xi is in Weber. Surface area is in meter square. So this should be Weber per meter square. Weber per meter square into meter square should be equal to the Webers. The unit should be consistent. Unit should be consistent. Right. So that is why the flux density is measured in the unit of Weber per square meter, and that Weber per square meter is also known as Teslas. It is also known as the Teslas. Right. Now why you are going to change the position of cross? Answer तो mathematically answer change हो जाएगा, but that is not the correct formula ना Manish. Okay, magnetic field is half k cross a n cap only. Okay. Okay Manish. Chalo. Okay. Now the one more Maxwell, the final Maxwell equation for static field, which states that the total flux through any closed surface in a magnetic field must be zero. Must be zero. Why? Why? This is because of absence of, you must be knowing these facts, revise कर लेते हैं एक बार, because of the absence of magnetic monopoles. There is no magnetic monopole. A magnet will always have a dipole, that is, a north pole and a south pole, and it is till now practically impossible to separate the north pole and the south pole. Still now practically impossible to separate the north pole and south pole, right? Okay, so integral B dot ds over any closed surface. So any closed surface if you take, idea is the magnet will always contain a north pole and south pole. Okay, and because of the two poles of opposite polarity, the surface integral turns out to be zero. Derive nahi kar rahe hain yahan pe, but you can take the direct result. Now, because it is the surface integral along the closed surface. Okay, surface integral along the closed surface is always simplified by Gauss divergence theorem. So what we apply here is the Gauss divergence theorem. After applying the, yesterday also we revised the Gauss divergence, na? Integral B dot ds over a closed surface is equal to the volume integral of del dot B. Volume integral of del dot B, but the result should be zero. That means the integrand must be zero. What is the integrand? Del dot B. So this is the final version of the fourth Maxwell's equation. Important form. Question producing area. We will see the question also, but this is one more question producing area. Divergence of B should be equal to the zero. The del dot B equal to zero, right? And because of this only, guys, one more thing, or just पे भी question लेंगे. Because the del dot B is equal to zero, right? We express B as a curl of some vector. We express B as a curl of some vector A, because divergence of curl is also zero. Vector property, mathematics property, divergence of curl is always zero. So we express B as a curl of some quantity, that is del cross A, where A is known as what? A is known as the magnetic vector potential. Magnetic vector potential, whose unit is basically Weber per meter. A is known as the magnetic vector potential. इस पे भी एक possible question हम discuss करेंगे, right? Yes, Amrit, correct. चलो. So if I have a look at the Maxwell's equation for the static electric and magnetic fields, this is for static. For the static electric and magnetic fields, what is the Maxwell's equation we have seen till now? Okay, one of the Maxwell's equation was related to the Gauss law. कल हमने देखा था last class, del dot D equal to rho V, and integral forms are also mentioned. Although for the question, let me tell you, okay, although for the questions, wherever questions are irrelevant, it will be more from the differential form. So del dot D equal to rho V. Okay, कल हमने question भी solve किया था. Given D, find the value of rho V and etc. Next, the potential difference between the 2 points is independent of the path between the 2 points. The work done in moving a particle from point A to point B is independent of the path between A and B, and that led to the next Maxwell equation, that electric field is conservative in nature. For static field, for time varying it will not be conservative. Static के लिए देख लीजिए, del cross E is equal to the 0, right? Then next we saw today del cross H equal to J, that is related to the Ampere's law. And finally we saw, because of the non-existence of magnetic monopoles, del dot B equal to the 0. Okay, these are the 4 Maxwell's equation for static field. Okay, let me also tell you the final form of the Maxwell's equation. Final form of the Maxwell's equation means, final form से मेरा मतलब है for the time varying fields, for the fields which are the function of time. ये भी देख लीजिए, for the time varying fields. Okay, then we take up questions combined on them. So del cross E is equal to the minus del B by del T. What? Del cross E is given by the minus of del B by del T, right? So del cross E, which is actually 0 for the static fields, so del cross E is not equal to 0 here. is not equal to 0. For the time varying fields, del cross E is given by minus del B by del T, coming up from the Faraday's law of electromagnetic induction. Derive nahi kar rahe hain, but you can take up this one. Del cross E equal to the minus del B by del T, right? Okay, chalo, next one. Okay, del cross H, Ampere's law. We call this as the modified Ampere's law. Actually, we call it as the modified Ampere's law. The modified Ampere's law, which says that del cross H equal to J, not only J was the conduction current density plus another term del D by del T, which is known as the JD. What is the JD? JD, which is the rate of change of displacement flux density. This is known as the displacement current density. This is known as the displacement current density. Displacement current density. Displacement current density, right? What is the J? J is simply known as the conduction current density. दोनों का formula भी लिख दिया मैंने. That is known as the conduction current density. The conduction current density is given by what formula? It is given by the formula sigma into E. JD is given by what formula? Del D by del T, or it can be epsilon del E by del T, because D is equal to epsilon E. So we can also write it as epsilon del E by del T. Right? Chalo. Okay, so this is known as the displacement current density, one of the modification given by the Maxwells. Okay. Del dot D equal to rho V and del dot B equal to 0. These two are same even for the time varying fields. There is no change here. These two will remain same for the time varying fields also. Okay, so the curl wala relation will change. Okay, why they are changing, we are not going into any derivation, but the final forms you must know, and these forms are related to which of the concept, that also you must know. What is one of the basics version of the Faraday's law? The basic version of the Faraday law, the induced EMF. The induced EMF is also given by minus N del xi by del T, rate of change of the total flux linkage through the circuit. Okay, where N is the number of turns. Okay, number of turns in the circuit, number of turns of wire in the circuit. Question देखेंगे अभी हम सब पे. Okay, right. चलो. So let us take into some question. Okay, then some more points we need to revise. उसको बाद में करते हैं. Magnetic forces को बाद में revise करते हैं. But let us go to a question now. Okay, then we revise magnetic forces and boundary conditions and etc. Right? Volume integral only for closed surface. If a constant value of radius is given, then I should take the limit, right? So now if you are doing the volume integral for a closed surface and if the divergence is constant, Manish, then the constant is outside and directly you can calculate the volume by 4 by 3 pi r cube if it is a sphere. Okay, so if you are assuming constant only, then we need not put the limit. Zarurat nahi padega. Okay, now let us take some questions and then revise more formula. Everybody come back here. The conducting wire of length 2 meter. The conducting wire of the length 2 meter is placed along the x-axis as shown figure. इसको थोड़ा सा और highlight कर देते. Is placed along the x-axis as shown in the figure. Let's consider this diagram. Okay, right. There is a current which is 10 ampere flowing in the wire and the length of the wire is 2. We need to find the magnetic field at 005. 005 means this point is on the z-axis. 005 is a point on the z-axis. This is a point on the z-axis. Okay, so because the point of observation is on the z-axis, हम क्या करेंगे, and the wire, usually you have the habit of seeing the wire as straight, vertical. Okay, तो इसको vertical बना देते. Let's take the x-axis as vertical. Have a look into this modified picture. Okay, just have a look into this modified picture. Okay, जैसा देखने का habit है, जैसा आपको solve करने का habit है, वैसे ही convert करेंगे. So let's say this is the x-axis and let's take the horizontal as the z-axis actually, because I need the point of observation on the z-axis. ठीक है जी? This is Z and this is known as the x-axis. On the x-axis there is a wire of length 2 meters. Okay, of length 2 meters. Okay, this is an important type of question. Everybody must be able to understand this. Okay, ध्यान देना. There is a wire of length 2 meters. Okay. This is the starting end of the wire, that is A. This is the ending end of the wire, that is B. Okay, my point of observation is somewhere on the z-axis, suppose P, which is 0, 0, 5. सबसे पहले क्या करेंगे? Let us join the point of observation with respect to both the ends of the wire, as I told you. ये लीजिए, दोनों से join कर लिया. Okay. Now, when you join it from the A, this itself becomes the perpendicular line. Automatically, the point, the line from A to P is also perpendicular. So, this will become the rho, perpendicular distance. And how much is the perpendicular distance? 0, 0, 0 to 0, 0, 5. That is 5. Okay. Then, what is the arrow direction? What is the direction along this line? So, this line is lying on the z-axis. So, what is the unit vector along the z-axis known as? It is known as the AZ. Okay. It is known as the AZ. Acha. Okay, then what is the direction of the current? ये भी mention करना पड़ेगा. The current is along the x-axis. How much is the current? The value of the current is 10 ampere and it is flowing along the x-axis. So what is AL? AL is known as the AX along the x-axis. Then sir, I need the value of alpha 1. Alpha 1 is known as what? Alpha 1 is known as the starting exterior angle, bahar wala angle from the starting end. So here it seems to be 90 degree. No need to calculate. It is clearly perpendicular. What is the alpha 2, sir? Alpha 2 is the interior. Already we have defined interior angle with the terminating end. What is the interior angle here? We can calculate. We can calculate tan of alpha 2. Opposite side. Tan theta is opposite side. That is equal to the 5 divided by the base of the angle. What is the base of the angle? 2 units. Okay. The length of the wire 2 hai. Okay. This length of the wire, this is equal to the 2 meters. Okay. So what is the value of alpha 2? Alpha 2 should be equal to the tan inverse of 5 by 2, that is 2.5. How much should this be equal to? एक बार निकाल लीजिए इसको. You have your virtual calculators available. 68.2. That is the 68.2 degree. ठीक है? 68.2. That should be the value of alpha 2. अच्छा जी. Okay. Now, what is the direction of magnetic field? वो भी लिखेंगे. So, let us apply the formula. What is the magnetic field formula? Sir, it is I divided by 4 pi rho cos of alpha 2 minus cos of alpha 1 A phi. How to calculate A phi? वो भी निकाल लेंगे हम. ठीक है. What is the current? 10. Let us put the values. Divided by 4 pi rho. 4 pi rho. Rho means perpendicular distance. Calculated as 5. Cos of alpha 2. Alpha 2 अभी निकाला 68.2 degree. Cos of alpha 1. Alpha 1 is the 90 degree. Okay, into A phi. Sir, what is the A phi? A phi, as I told you, the formula for direction of magnetic field. Either right hand thumb rule or either the formula. Apply the formula, straightforward answer आ जाएगा. It is AL cross arrow. What is the AL? What is the direction of current? X. Cross arrow. देख लीजिए, arrow is Z. What is the X cross Z, sir? What is known as the X cross Z? Z cross X is positive Y, na? According to the direction. X cross Z will be minus AY. Basics है ये तो. X, Y, Z are mutually perpendicular. Okay, and Y cross Z, Z cross X is Y. So X cross Z is automatically minus Y. तो यहाँ पे जो direction है minus AY. And because we are calculating magnetic field, so its unit is ampere per meter. Okay, just calculate the value. Cos 90 degree is going to be 0. Place down the value, minus बाहर ले लेंगे, and final answer, how much it is? Okay, so this is turning out to be, final answer is turning out to be minus of 0.059 AY ampere per meter, or if you want, you can write it as minus of 59 AY in the form of milliampere per meter. So इसको मैंने लिख दिया minus 59 AY milliampere per meter. That is also possible. Okay, depending on what is the option, units given in the options. Cool. Important, but simply solve this question. Okay, chalo. One more question based on the direction. Important hai ye bhi. Okay, such questions are again important. So please find out. Two infinitely long wires. The question is on long wires, but formula की जरूरत ही नहीं है, whether it is long wire or finite wire. This question is only going to talk about the direction. Okay, so two infinitely long wires carrying the currents are as shown in the figure. One of the wire is in the YZ plane. Here, one of the wire is in the YZ plane and parallel to the Y-axis. This is the first wire. Okay. Then next wala. The other wire is in the XY plane. So this is the other wire and it carries the current parallel to the X-axis. The current is parallel to the X-axis. Which components of the resulting magnetic field are non-zero at the origin? Which components of the resulting magnetic field are non-zero at the origin? Yes guys, can we solve and give the answer? Which components are non-zero at the origin? Have a look into this. Okay, this one is my first wire and this one is my second wire. Now, in the first wire, what is the direction of current? Direction of current is known as AL. So, what is AL1? The first current is along the y-axis, that is AY. Right. Second one, what is the direction of current? AL2, that is known as along the x-axis. So, dekho, AL2 is AX. Because to find out the magnetic field direction, what I need? AL cross, AL cross arrow. What is the arrow? Which components of the magnetic field are non-zero at the origin? We are interested magnetic field at origin. We are interested for the magnetic field at origin. ये ले लीजिए. We are interested for the magnetic field at the origin. ठीक है? चलो. All cool. Okay. So what is this? Let us draw the perpendicular from the axis of the first wire to the point of observation and from the axis of the second wire to the point of observation. How much is this? This is known as the A rho 1 perpendicular direction that is flowing in the minus Z, or this is known as the A rho 2 perpendicular for the second wire, or ये minus Y direction में जा रहा है. Okay, now I have very simple answer. Magnetic field H, total magnetic field according to the superposition should be H1 plus H2. Okay, sir, what is H? Okay, what is H1? H1 is in the direction that is known as A phi 1. And what is the A phi formula? Direction of magnetic field is always A phi, and A phi is given by the AL cross arrow. AL cross arrow. AL1 cross arrow 1. What is the AL1? AY. Cross arrow 1? AZ. What is Y cross Z? Is known as X. Okay, now what is the H2? H2 will be in the direction A phi 2. A phi 2 will be given by AL2 cross arrow 2. Sir, what is the AL2? Second current is in the X direction and the arrow is in the minus Y direction. X cross Y is Z, so X cross minus Y is minus Z. Plus or minus se bother nahi karna hai, but the total magnetic field, the resultant magnetic field will be having a component in the X direction and one component in the Z direction. X and Z components will be available. So option number D is my correct option. Got it all? Right. If you keep learning, if you keep enjoying, okay, do mark up your attendance. Attendance is, YouTube mein attendance is like or dislike button, anything. Okay, your presence of mind should decide that, but something, some interaction, some response should be there. Okay. I'll update about that, Biswas. Let's wait for that. Let's look into the time. What is this? The magnitude of the magnetic field intensity. Okay. At a radius of 2 meter from a long linear conductor is 1 ampere per meter. How much is the current in the wire? Okay. Long linear. Linear means straight conductor. Long straight conductor. Long means how long? Okay. Long means how long? Why minus, Ritesh? Why minus in H1? Why minus in H1? कौन सा बोल रहे हो? H2 में बोल रहे होगे आप, not in the H1. H1 is okay. Y cross Z is X. It is plus only in the H1. Okay. Long straight conductor, everybody. Okay, so what is the magnetic field due to a long straight conductor is given by the formula H. देखो direction कहीं नहीं बोला है. So what is the H is simply given by the formula I divided by 2 pi rho. Right. The actual formula is, okay, the actual formula is H is equal to I upon 2 pi rho A phi. अगर direction अगर vector form में रखें. Okay, but I only want the magnitude of H. Magnitude बोला है. Okay, we call it as simply H, and that is simply I divided by 2 pi rho for a long conductor. Okay, magnitude कितना होगा is 1 ampere per meter. Magnitude is given. Okay, how much current must flow to produce this magnetic field? So I divided by 2 pi rho, rho is 2. Okay, at a radius at a distance of 2 meter, तो I कितना हो गया? The current that must flow is the 4 pi ampere. Current that must flow is the 4 pi ampere. Option number A, very simple question. अच्छा, it is there in the comment box also. Already option number A. ठीक है जी? बहुत बढ़िया. This can be simple. So there can be some good conceptual question. There can be few simple question. एक और देख लेते. This is again direct simple question. How much current must flow in a loop? Okay, loop. What is the formula for? Okay, loop. Okay, magnetic field 1 at the center. By default, nothing is mentioned. So magnetic field 1 milliampere per meter at the center. So what is the formula of magnetic field due to a circular loop at the center? That is given by the formula. Just now we revised na, I upon 2 rho a n cap. Rho is the radius of the loop. Lekin once again only magnetic field intensity is given, magnitude is given. So what is the H? That should be simply I upon 2 rho. How much current must flow to produce the magnetic field 1 milliampere per meter? 1 milliampere per meter is equal to I divided by 2 rho. Rho is known as the radius. Radius is given as 1. So how much is the current? Twice of 1, ye milliampere mein hai, so current will also be in the milliampere. 2 milliampere, option number C. Simple. I'm telling you, some good questions, some simple question, anything can be expected. Let us be prepared for all. Okay. Okay, next. Now this is again a good question. This is again a good question here to be discussed. Yes guys, chalo. Let's see this. Two identical copper wires. Okay, once again length not mentioned. There are two identical copper wires. Length not mentioned means by default long length, infinite length. The wires are W1, W2. They are placed parallel as shown in the figure and they carry the currents I and 2I but in opposite direction. One of them will carry current I, another one will carry the current 2I but in the opposite direction. If the two wires are separated by a distance of 4r, ये total distance 4r होना चाहिए. What is the magnitude of the magnetic field B? Okay, B is actually known as the magnetic flux density. Okay, magnetic flux density. Okay, and that is given by mu into H. What is the mu here? Nothing is mentioned. So free space लेंगे तो mu will be mu naught. So let's take B is equal to the mu naught H and H formula we know, right? Between the wires at a distance r, at this distance r from W1. Okay, have a look into this picture once again. Have a look into this picture once again, everybody. Okay, these wires carry the currents I and 2I, but which is carrying the current I? Not mentioned. So let's take this as carrying the current I, but in opposite direction. Okay, so जो भी आप assume करना है, you can take I on the above or I on the below, does not matter, but they should be opposite direction, one forward to one backward. Okay. To be simple with the direction, let's assume these coordinates. Okay, let's assume that this is X and this is Y. Let's assume that. Horizontal is X, vertical is Y. Okay, acha. Then I want the magnetic field, let's suppose at a point P. Okay, total distance between the wires is how much? Total distance is 4r. Okay, I want the magnetic field at distance r from W1. Okay, so if this is the r, this one will be named as 3r. Okay, what is the perpendicular distance from the axis of the wire? What is the perpendicular distance from the axis of the wire? Okay, so ये देखो, ये हो जाएगा AL1, direction of first current, AX according to this. So what is the direction of the second current, sir? The direction of the second current will be minus X, opposite direction. Then what is the arrow 1? Arrow 1, perpendicular from the first wire, नीचे की तरफ है, that is minus Y. What is the arrow 2? Perpendicular from the axis of second wire, that is vertically upwards, AY. I have assumed, you can assume any axis, कोई फर्क नहीं पड़ने वाला है. Okay, you can assume any axis, right? So, what is the total magnetic field, sir? To solve this, I need H, which is H1 plus H2. What is the H formula? I1 is divided by 2 pi rho 1 A phi 1. H2 formula will be I2 divided by 2 pi rho 2 A phi 2. ठीक है जी? Basically wire of infinite length, long wire formula, long wire field formula. What is the first current I1? That is I. Divided by 2 pi. What is the rho 1? This is known as the perpendicular distance from the first wire, that is R. Okay, into A phi 1. A phi अभी निकाल लेंगे. How to write down A phi 1? AL1 cross A rho 1. So AX cross minus AY. What is the second current, sir? Second current is known as the 2I divided by 2 pi rho 2. What is the perpendicular distance from the second wire? This is known as the 3R. Is multiplied by the A phi. What is the A phi? AL. Second wala AL है minus AX cross AY. Cross AY. ठीक है? Now x cross minus y or minus x cross y, both will be equal to minus z. Actually x cross y is z, so x cross minus y या minus x cross y will be minus z. मतलब both are in the minus z direction. What all you can take common? क्या क्या common आ जाएगा? I is divided by 2 pi r common है. Okay, यहाँ से आया 1. I upon 2 pi r के अलावा what is left is 2 by 3 and minus of x cross y is minus z. Okay, so what is the total magnetic field here? The total magnetic field will be 1 plus 2 by 3 हो गया 5 by 3. So 5I divided by 2 pi r into 3 will become 6 pi r and direction is minus z. What is the total magnetic flux density then? B is mu naught H, right? And that is going to become minus 5 mu naught I divided by 6 pi r in the z direction. Direction was our assumption. That is why, because there are no direction given, they've asked the magnitude only. Okay, so what is B? The magnitude part. So z or minus sab hata denge. The magnitude is 5 mu naught I divided by the 6 pi r, and hence the correct answer is 5 mu naught I upon 6 pi r. So the correct answer is option number C. Cool. The correct answer is the option number C, everybody. The correct answer here is the option number C, right? Chalo. Next question, simple one. पहले हाँ ये है, ये वाला बता दीजिए पहले, right? चलो. Yeah, this one was Darshana, yes. Okay, but not the previous one, only this one. What is the value of magnetic flux in Webers if it is 2000 in Maxwell? So there are two units of the flux. As I told you, flux is measured in WB, that is known as the, I was mentioning that there will be one more unit जो मैं discuss करूँगा, that is in Webers, or it is measured in mx, it is known as the Maxwells, right? What is 1 Weber? Forget this question. What is 1 Weber equal to? What is a 1 Weber equal to? How much is 1 Weber? Can anyone say? 1 Weber of flux is equal to how much in Maxwell's? Then this question is simple lollipop. You must know that unit conversion. Can anyone say that relation? How much is 1 Weber equal to the? If you know this, if you remember this. Yeah, anonymous comes up with some answer. Plus 8 or minus 8 anonymous? Just check it up. Yes, Divya, Simran, right? कभी कभी आ जाता है गजेंद्र, कभी कभी आ जाता है out of the box 1 mark. Okay, it is given by the unit 10 raised to the power 8 mx. Weber is a large unit compared to the Maxwell, 10 power 8 mx, right? So we just have to remember this point. कभी कभी इससे भी सिंपल यूनिट वाला गेट में पूछा गया, डायरेक्टली यूनिट, नॉट इवन द यूनिट कन्वर्जन. ओके, अच्छा. सो नाउ इफ इट इज 2000 इन मैक्सवेल, if it is 2000 in Maxwell, so I can say how much is 1 Maxwell? 1 Maxwell is 10 power minus 8 Weber, right? 10 power minus 8 Weber. So how much is 2000 mx? 2000 mx is 2 into 10 raised to the power 2000 into 10 power minus 8, 2 into 10 power minus 8 Weber, 2 into 10 power minus 5 Weber. That is the option number A. 2 into 10 power minus 5, right? Chalo. Right. Darshana, Tesla is the unit for flux density. Okay, not for flux. Okay, Tesla is 1 Weber per square meter. Acha, next. Now this is the question. I told you the one expected question. What is the current density J if the magnetic field is given to you? So how do you calculate Ampere's law basically? According to the basics Ampere law, J is given by the formula del cross H. J is basically given by the formula of del cross H, everybody. What is the J? It is given by the formula del cross H. Very simple question, curl question. That too the vector is in the Cartesian coordinate system. So J, which is the del cross H. Let's close this quickly. Curl calculation, that too only in the Cartesian coordinate, Ax, Ay, Az, del by del x, partial derivative terms, del by del y, del by del z, and then we have the vector component 3 and the 7y and the 2x. 3 and the 7y and the 2x, right? 3 and the 7y and the 2x, everybody, right? So how much is this equal to? Ax, del by del y of 2x is 0, del by del z of 7y is 0, minus ay, del by del x of 2x is 2, del by del z of 3 is 0, plus the az, del by del x of 7y is 0, del by del y of 3 is 0. So only the y component is there. Answer is minus 2ay. That means option number A. Same thing is there in the comment box already. Correct answer number A. Okay, correct is answer number A. Option number A is the very correct answer. Is a very correct answer. Next question. Given the magnetic vector potential, okay, A is equal to 2yax minus xay Weber per meter, what is the magnetic flux density? So this is based on magnetic flux density B, which is curl of A. Magnetic flux density B, which is curl of A. Okay, this one is again simple, again a curl based question. Magnetic flux density B, which is given by the curl of A, which is given by the formula del cross A, everybody, which is given by the formula of del cross A. तो चलो check कर लेते हैं. Again the vector is simple, Cartesian coordinates में है, ax, ay, az, but you can expect the question in all coordinates, okay? Cylindrical coordinates, spherical coordinates, and then यहाँ पे आ गया x component is 2y, y component is minus x, and z component is 0. Right, so basically only because it's a function of only x, y, केवल normal component z component will be available, and the answer in the z terms will be del by del x of minus x minus 1, del by del y of 2y is 2, and my answer is going to be minus 3az. Minus 3az, right? Now this is the flux density, that is why it is in Teslas. Teslas or, okay, Teslas or Weber per square meter. Okay. So this one again the simple question. Right. Chalo. All cool. Let's go in the sequence only. All going fine. Kahan chala gaya? Haan, this is what we have done. Yeah. Let's go in the sequence. We have abhi sufficient time. If the vector B is given to you, x square ax minus xy ay minus kxz az, which represents a magnetic field vector, that is the magnetic flux density vector, what is the value of the constant k? So this is based on the final Maxwell's equation we saw. Okay, if it is a magnetic field or magnetic flux density vector, it should satisfy del dot B equal to the 0. Divergence of B, okay, once again simple because it is in the Cartesian coordinate. So what is the divergence of B formula? So del by del x of the x component plus del by del y of the y component hai minus xy, plus del by del z of the z component, that is minus kxz. Total 0 hona chahiye, right? So 2x minus x, differentiation with z, minus kx is 0. So basically 2x minus x minus kx equal to the 0. So solve करके k का value क्या आएगा, right? After solving this, x is common, 1 minus k equal to 0, and hence what is the value of k? K should be in general equal to the 1. Option number B. K is the 1. Simple question. Okay. But there have been similar questions, not the same but related questions in the GATE. Okay. Chalo, k equal to the 1. K equal to the 1. Next question, guys. Now, in a certain conducting region, H is given to you minus 4y cube AX ampere per meter. What is the current through a square of side 1 meter with the corner at the origin and the sides coinciding with the positive x and y axis? Current through a square, I'll just show you this square. The sides are coinciding with the x and y axis respectively. ये भी बोला है. We need to take up a square. Okay, something of this form. Okay, with the corner at the origin and the side of the square is 1. Okay, in a certain conducting region, the magnetic field is also given to you, and these axes are x and y axis. What is the current through the square of side 1 meter? How to calculate this current, guys? How we are going to calculate this current? देखो current कैसे निकालेंगे? I'll give you the idea. Current कैसे निकालेंगे? Current is actually given by the Ampere circuit law number 1, integral h dot dl. Basically Ampere's law over the closed path. Okay, Ampere circuit law. ठीक है. But we can also apply the Stokes theorem onto it, and we can write it as integral del cross h dot ds. That is what is the Stokes law. Okay, or we can also write it as integral j dot ds. Del cross h equal to the j. ठीक है. But यहाँ पे आप देखोगे, I will give you one more hint. The magnetic field H is in 2D. Okay, is a two variable function. The magnetic field is a two variable, actually x or y, it's a two variable, it's in 2D. It's a two variable case, right? जो path given है, that path is also in 2D. It's in the xy plane. It's not a 3D path, it's only in 2D, right? So better what we can use is, because of this two variable condition, Stokes is always convertible to the Green's theorem. Rather than the Stokes theorem, you can apply what? You can apply the Green's theorem. Sir, what is the Green's theorem? I, which is integral h dot dl. Integral h dot dl can be further written as integral hx dx hy dy. This is how we open the line integral, na? 2D mein hai integral hx dx plus hy dy, and that can be written as double integral of first differentiation with x of the y component minus differentiation with y of the x component. Del by del x of hy minus del by del y of hx dx dy. You can directly use this formula and now solve. Yes, guys. What should be the answer? Kindly take it up and give me the answer. Double integral del by del x of hy minus del by del y of the hx dx dy. Okay. Chalo. So let's take it up then. What is given to me? X component is minus 4y cube. ये हो गया del by del y. Del by del x of hy. Hy is 0. There is no y component. There is only the x component. Okay. And the value of the x component is minus 4y cube. The minus 4y cube. Right. So ये कितना हुआ? This is 0, minus getting plus, 4 3s are 12, double integral of y square dx dy. Okay, yeah, let's complete this integral. 12 dx का integral is just x, variables are separable. Y square का integral is y cube by 3. Now what should be the limit? Because it's a rectangular portion, limits constant होगा. X is 0 से 1, y is also 0 to 1. Okay, तो x limit is 0 to 1, y limit is also 0 to 1. तो cancel होके कितना आ गया? It is 12 by 3 cancelled as 4, then 1 minus 0, and y cube का भी limit 1 cube minus 0 cube, that is also 1. So the answer is 4. What is the final answer? Is the 4 units, sir. 4 units. That's it. ठीक है, the answer is 4 units, 4 amperes. Okay, amperes में बोला है, so my answer is 4 amperes. Okay, chalo, all good. Then we have the next question coming up on the screen. The plane y equal to 0 carries a uniform current. The plane y equal to 0 carries a uniform current density minus 20k milliampere per meter. Okay, what the magnetic field intensity? The magnetic field intensity at x equal to 1, y equal to 10, z equal to minus 2 will be. The magnetic field intensity at x equal to 1, y equal to 10, z equal to minus 2 will be. So now plane means an entire plane carrying a current. The plane y equal to 0 carries a current. The plane y equal to 0 carries a current. An entire plane is like entire sheet, an infinite sheet of current. So this question is related with the concept of infinite sheet of current. Right? Y equal to 0 means xz plane, and that is an infinite sheet of current, and that carries, that infinite sheet of current is having the current density of minus 20k cap. Yeah, in our terms it can be written as minus 20 az along the z direction milliampere per meter. What is the magnetic field at the point x equal to 1, y equal to 10, z equal to minus 2? Acha, y equal to 0. Y equal to 0 is also known as xz plane. Okay, y equal to 0 is also known as the xz plane. Okay, have a look into this picture. Formula already I have told you. Let me just draw this picture slightly so that you can come up with some formula and some answer. Okay. Y equal to 10. So the y equal to 0 sheet, y equal to 0, let's consider this sheet. Okay, it carries the current in the minus z direction. Okay, this is z, this is the positive z, outwards direction. Okay, so what is the minus z? इसके reverse में minus z जाएगा. This is the k which is, this is the k which is minus 20k, minus 20k. Which is minus 20k. Okay, this is the k which is minus 20k current density. Okay, what is the magnetic field at the point x equal to 1, y equal to 10? देखो y axis के respect में point is y equal to 10, positive y, right? Positive y. Okay, so point, let's say randomly somewhere here, this is the point of, this is point P, 1 comma 10 comma 1 comma 10 comma minus 2. Y का value positive है. We have to draw a unit vector. We have to draw a unit vector. Okay, normal to the sheet and towards the point of observation. Normal to the sheet and towards the point of observation, because that is going to tell what is the A n cap. A n cap is in the plus y direction, right? Formulas we have already discussed, right? What is the formula? Very simple question now. Just have to apply the formula. What is the formula for magnetic field H? It is given by half k cross A n cap. चलो, half k cross A n cap. A n cap भी आपके सामने है, k भी आपके सामने है. Quickly conclude and kindly give me the answer very soon. Okay, and just allow me a minute also by that time. Oh, not this one. Check इसका setting बनना है. 1 minute will be more than sufficient. I think many of you already solved this. Allow me 1 minute. By that time, you please solve it up. Yes, so time's up. Okay ji, yeah, so what is the answer that you guys have concluded? That is the half k. K is minus 20 az cap, cross the an cap. An cap is ay. Right, so minus of z cross y means y cross z, that should be x, so it should be plus 10 ax. Magnetic field plus 10 ax ampere per meter. Plus 10 ax ampere per meter, that is option number B. 10 AF and 10 I cap. Option number B. Yeah, same thing is seen in the comment box also. Option number B. All cool. Correct answer. That is the option number B. Option number B. Next one. The next one. In a 100-ton coil, if the flux through each turn is TQ minus 2T milliweber, what is the magnitude of the induced EMF in the coil? Induced EMF in the coil. Faraday's law. This is a question on the Faraday's law. This is a question on the Faraday's law. K will be given na AKJ. Current density, the source has to be given. Then only you can find the field, okay? What is the induced EMF in the coil? So what is the Faraday's law basic version? We already revised in one of the case. The induced EMF, you can calculate it as minus N del xi by del T. Del xi by del T, right? What is the xi? What is the flux through each turn is T cube minus 2T in the form of milliweber, and the number of turns, it's a 100-turn coil, N ka value 100 hai. So what is the induced EMF is given by minus of 100 del by del T of the xi, that is T cube minus 2T. Okay, that becomes minus of 100. अच्छा, T cube minus 2T milliweber है, तो 10 power minus 3 अब multiply करते हैं. 100 into 10 power minus 3 is basically 0.1. Okay, differentiation करके मिला 3t square minus 2. Okay, we need the value at the t equal to 4 seconds. We need the value at the t equal to 4 seconds. So at the t equal to 4 seconds, induced EMF will be minus of 0.13 into t square, that is 16 minus 2. So that is equal to how much? 46 into 0.1 minus of 4.6 volt. How much is the induced EMF? Minus 4.6. Magnitude पूछा है केवल. So magnitude will be of course plus 4.6. Option number C. Yes, yes, yes in the comment box also. It is the option number C. Simple. Faraday's law of electromagnetic induction. Acha. Next case. A conducting circular loop of radius 20 centimeter lies in the plane z equal to 0 in the field B, which is 20 sine 300 t milliweber per square meter. What is the induced voltage and induced EMF once again? Guys, let me tell you that whenever there is a circular loop that is not moving, nothing given means not moving. So there is some stationary loop which may be circular or rectangular or any shape, does not matter. There is a stationary loop, closed loop. Okay, there is a stationary loop in time varying B field. In the time varying field, B is a function of time. Okay, the EMF that is generated is known as the transformer EMF. This is known as the transformer EMF. Basically related with the Faraday's law only, right? Let's wait for the official confirmation, Abhishek by IIT. Let's not put any conclusion. Okay, we can't say anything right now. Transformer EMF. And formula you have to apply the same. VEMF is given by minus N del xi by del T. But how to calculate del xi by del T, that I am going to explain. What is the value of N here? What is the value of N here? N is 1. There is a circular loop. A loop means a single loop is there. A single loop is there. Now, how you are going to calculate the xi? Try to understand how you are going to calculate the xi. Let's make it as a general formula. Okay, isko generally dekh lete. This can be asked sometimes in the exam. What is B? B is 20 sine 377. So let's say B is equal to B naught sine omega t, right? Sine omega t. इसको simple कर दिया हमने. Okay, तो let B is equal to B naught sine omega t. अच्छा जी, right? Now how do you calculate the flux? It is integral B dot ds. It is integral B dot ds. Now one more thing to be noticed here. Okay, the loop, okay, the circular loop is in the z equal to 0 plane. The loop is in the z equal to 0 plane. So जो मेरा loop है, that is in the z equal to 0 plane, right? So what is the unit vector normal? Z equal to 0 means xy plane. Z equal to 0 means xy plane. And what is the vector normal to the xy plane? What is the vector normal to the xy plane is z direction, right? What is the direction of any surface area? The direction of any surface area is also z direction. What is the B? B is also in the z direction. B is given in the z direction. Both are in the same direction. So if there are two vectors in the same direction, what is A dot B? Is AB simply. What is A dot B? Simply AB. I'm just explaining you a little bit. So this becomes integral B ds, right? B is a function of only time. B is a function of only time. It is not a function of the surface area. So B is outside and then I write down integral ds. What is the value of integral ds? Everybody should know it is the surface area, right? It is known as the surface area. Acha ji. It is known as the surface area. So now what is the V EMF? It is minus n del xi by del t. What is the value of xi? It is B into S. B is a function of time. S is the surface area which is constant. So ये हो गया minus ns del B by del t. Minus ns del B by del t. अच्छा. What is the value of B? The value of B I have assumed as some amplitude B naught sine omega t. Right. So after differentiating, what is the induced EMF you are going to get? Minus ns B naught sine omega t ka differentiation omega cos omega t. That's it. Minus ns B naught omega cos omega t. Right. What is the peak voltage? Sometimes they can only ask the peak voltage. Peak voltage means amplitude. So what is the amplitude? Ns B naught omega. Okay. This is just like A cos omega t, na? This is just like A cos omega t. Right. So it is Ns B naught omega. Ns B naught omega. That's it. Peak voltage is Ns B naught omega. Acha, let's come back to the question. First of all, so what is the induced EMF here? What is the induced EMF? इस question को अगर हम complete करें, so for the particular question we need the induced EMF, that is minus Ns, okay, minus Ns B naught omega cos omega t. Minus Ns B naught omega cos omega t. What is the B given to me? The B was given to me. Now let's value put करेंगे. 20 sine 377 t Az milliweber per square meter. Okay. How many turns? 1 turns. Right. Surface area, circular loop है ना, तो what is the area of that circle? Area of that circle is pi r square. Area of the circle pi r square. Radius है 0.2. 20 सेंटीमीटर है तो मीटर में कन्वर्ट किया. B naught 20. Omega 377. Right, into cos omega t and into 10 power minus 3, right, volts. Milli की वजह से 10 power minus 3. That should be the final answer. Just let us complete the calculation, guys, and let's see what is the final answer that is turning out. Final answer after all the calculations. Okay, so approximately it is turning out to be minus 0.95947, so minus 0.95 cos of omega t. This is the induced EMF function, right? Minus 0.95 cos omega t. Guys, why you are even thinking about exam? See, guys, okay, I know it's a test of patience, but why? Just imagine that gate is not postponed. Unless and until there is news, let us not imagine, because that imagination also will waste your time. I know many students are worried whether the exam is going to happen on time or not happen on time. There is no declaration by the IIT as of now. Okay, there is no declaration by the IIT as of now. But why we are thinking about this? Let us say that, okay, sometimes you have to make your brain, heart, everybody a fool. You have to make them a fool. Okay, although you might be thinking something else, but जो reality है, जो practical thing है, उसके बारे में सोचना पड़ेगा ना. And you should just make a conclusion that I don't know about any notification right now. I don't know about any COVID situation. I don't know about any cases right now. Okay, right? Don't read the newspaper, don't read the news. Okay, otherwise you will keep every day, what is the COVID situation, will it postpone? You will not think with respect to COVID, but you will read the COVID news because of the exam getting postponed or not. Just forget it. Only thing is study, study, study. Because if it is not postponed, you are into trouble. You are into trouble. Okay, but if it is postponed, later on you can enjoy the benefit. So don't think about this. Soch bhi kyun rahe ho? So why you are telling it as patience and all? Forget. I don't know anything. If there is something, IIT will tell you na. And as per my experience, I'm telling you na, by 15, 16 notification should confirm. See, anytime it can come. It may come tonight. It may come within 1 minute. It may come by tomorrow. So IITs are also trying to figure out the situation. चलो एक बार आपके सामने check कर लेते हैं. My laptop is just in front. See, there is nothing as of now. I also just keep checking. Okay, there is nothing as of now. Okay, हो सकता है अभी आ जाए, next second में आ जाए, या maybe by tomorrow. But I believe tomorrow is again what, Thursday, na? I believe by this weekend, you know, or maximum Monday will be what, 17th. They should come up with some conclusion. Maybe possible today, tomorrow, day after tomorrow, but some conclusion will come up very soon. Okay, somewhere around 15, 17 tak I think conclusion aa jana chahiye. Okay, by that time you don't have to think anything. Exam as of now they have not mentioned postponed. So as of now you officially also it is 5th, 6th, 12th, 13th February. You cannot question anybody. Okay, you cannot question. Agar kuch garbad bhi hua to you cannot question anybody. In the website it is still 5th, 6th, 12th, 13th. That's it. Yehi dhyan rakhna hai. Right, they have not even removed the dates. Okay, chalo, let's move ahead to the next question. Acha guys, because we have solved this, one more thing I should tell you. Okay, okay, sometimes if they can put up a question, okay, if there is a moving loop, okay, in uniform field, if there is earlier there was a stationary loop, now there is a moving loop, rotating loop, okay, in a uniform loop, okay, the type of EMF that is developed is known as the motional EMF, right, whose amplitude is given by, actually coincidentally the formula will be same. That is why, okay, मैं formula बता देता हूँ. Final formula जो है ना peak voltage का, that will remain to be same, NS B naught omega. That's it. Simply remember the same formula here, NS B naught omega. Okay, right, chalo. Okay, let's move ahead to the next then. Next. Acha. Next, let me also take you towards slight revision. You should just know the formula. That's it, sufficient. If you know the formula also, na, that will be sufficient. Okay, let us know the formula for. Acha. Before that formula, let me once again update you. Okay, that this Sunday, okay, that is 16th of January. Yesterday I told you the dates will be announced. So yes guys, those who haven't done anything of aptitude, ya agar kar liya, still they want some little bit revision very quickly. So let's try to achieve the full 15 marks in the 15 hours. Okay, there will be a daily 5 hours marathon. Okay, for 3 days. Okay, and because I say 15 marks, so it will be including the verbal also, quantitative, DI, spatial aptitude, logical reasoning, verbal, everything. Okay, right, so that is what timings I'm not real because timing discuss nahi ho paya, but whatever is the timing also I will announce by tomorrow. Okay, chalo. So general aptitude Maha revision marathon, okay, live from the Sunday 16th of January, 3 consecutive days it is going to be. Okay, 3 consecutive days. Okay, what you should just do is just keep on subscribing, just keep subscribe to the channel, because as I told you, not only the aptitude, but there will be so many things coming up entire month. Aptitude aayega, maths aayega, the GATE Premier League. Tomorrow I will announce you that also. The GATE Premier League, the BYJU'S Exam Prep GATE Premier League, the GATE Championship, the final round of testing for GATE is also coming up very soon. In the similar manner, just like IPL, some teams competing like, you know, CSK versus RCB, RR, Sunrisers Hyderabad, like that. Right? We are going to make it in a little bit fashionable manner so that it is fun studying. So live quizzes on the YouTube also coming up. Okay, most likely after the aptitude marathon. So GATE Premier League. Okay, a short duration GATE Premier League just to test your last moment performance. And live quizzes will be coming up. Okay, and the team's name will be little bit similar to some of the Premier Leagues. Okay, so you'll enjoy it. It will be fun. It will be a fun-based event with the learning. Okay, with the learning. Okay, so that will come up shortly in the same channel. Okay. Yeah, Alan, you remember that team, but there will be many more teams. There will be many more teams this time. Okay, chalo. So guys, yeah, let us revise some more formula. The next formula is forces. Basically, very basic question you can expect. Okay, menti ke form mein hoga, Nitesh. Chalo, it's going to be in the form of menti only. The forces due to magnetic fields. The forces due to magnetic fields. Okay, so experimentally it has been observed that only a moving charge can experience a force in the presence of magnetic field. Stationary charge cannot experience any force. The magnetic force is given by the formula Q into U cross B, where U is the velocity of the moving charge. If the velocity is 0, the force will also be 0. So a stationary charge will not experience any force, right? Let me tell you the final force equation in that case. Okay, the final force equation, okay, experienced by a moving charge in the presence of both electric and magnetic fields will be given by Fe plus Fm. Sir, what is the Fe? Coulomb's law. Fm, just now I told you what is the Fm? Q into U cross B. Right, and Fe, Coulomb's law, Q into E. That is by the Coulomb's law. Yesterday we studied electrostatic force of attraction or repulsion. Adding both, if there is a moving particle in the presence of both electric and magnetic field, then the net force is given by Q, common lete hue, E plus U cross B, and that is simply known as the Lorentz force equation. Okay, so if there is a simple question, you can easily solve it up. I am just revising the formula for the force. Acha, what is the force that is experienced by a current element? Okay, the current element, let's suppose there is a small current element ideal. Okay, a small current element ideal. The small force experienced by that small current element in the presence of magnetic field is given by the formula IDL cross B. Yeah, we can also say that total force is IL cross B. IL cross B. Okay. So these are some of the formulas that you must know. Acha, one more important thing that they can discuss from here. Okay. You should remember these points, some conclusion. The Fm is given by Q into U cross B. Now there are 2 or 3 important cases that you should remember. What are the 2 or 3 important cases? Number 1. What are the 2 or 3 important cases? Number 1. If the particle moves with a velocity parallel to B. Okay. If a particle is moving with the velocity which is parallel to the direction of B field, okay, in the B field direction, then it will be following what path? Can anybody comment? What is the path of the particle? Okay. What is the path of the particle? Basic calculus apply karke aa jata hai, but we need not derive. I'm just commenting you. Okay, let's wait for your comment. Second, if velocity, okay, is perpendicular to the B. Next case, if the particle moves with a velocity which is perpendicular to the B field, then it follows what motion? Right. Pranay, if you are asking for EMFT, the best book for basic concept clearing is Sadiku. All variety of question relevant to GATE except 1 or 2 topics like, circular waveguides or optical fibers may not be relevant there, rest you can follow. Yes, correct. So it follows the linear path. It keeps on moving in a linear manner, straight line. Okay, if U is perpendicular to B, then the particle will move in a circular path, right? And the next case, combination of that, if suppose U is a combination of 2 components, if U is a combination of 2 components such that one of the component is parallel to B field, one of the component is perpendicular to the B field, Okay, so one of the component will try to make the particle move in circular path, but another one will try to make it in the straight line linear path. एक आगे की तरफ लेके जाएगा, एक सर्कल में घुमाएगा, then it will form a helical path. Okay, then the particle will be moving in a helical path. Okay, these are some conclusions from which you can expect the question. This is a very basic review of the magnetic forces that you must know. ठीक है, अच्छा जी. Now let's move to the next question. Already I told you about this event. So Sunday को हम time इसका मैं कल बता दूंगा. And be ready for the GATE Premier League. The GATE Premier League to test your preparation, to test your championship right now. The GATE Premier League is also going to come up. BYJU'S Exam Prep GATE Premier League. चलो, ये रहा नेक्स्ट क्वेश्चन आपके लिए. An interface Z equal to 0 between two general materials contains a uniform surface density rho s equal to 10 power minus 9 coulomb per square meter. Okay, now boundary condition also let us revise as I told you. Sadiku Pranoy. Okay, Sadiku SADI KU. SADI KU. Okay. An interface Z equal to 0 between two general materials contains a uniform surface density, charge density, rho s 10 power minus 9 coulomb per square meter. Electric field in material 1 occupying to the left of the interface Z equal to 0 is given. Epsilon 1 is 4 epsilon naught and electric field is given. What is the electric field intensity in the material 2 occupying to the right of the interface Z greater than 0? Boundary condition. Okay, this question is based on the electrostatic boundary condition. तो वो भी revise हो जाएगा आपका यहाँ पे. So let us review the electrostatic and magnetostatic both. Okay, first let me make the picture here. Okay, the boundary is being separated by Z direction. Z equal to 0, Z less than 0 and Z greater than 0. ये रहा Z axis. Okay, now let me make the boundary for you. Let's say this is the boundary. Okay, this is the interface. This is what is the interface. That interface will be known as Z equal to 0, right? This is the first region which is Z less than 0 and then this will become the second region that is Z greater than 0. Acha, the interface carries some surface current that is given by the value 10 power minus 9 coulomb per square meter. Okay ji, chalo. Right, in the region 1 Z less than 0 epsilon 1 is equal to 4 epsilon naught. यहाँ पे क्या है? यहाँ पे epsilon 1 is given by the 4 epsilon naught and here the epsilon 2 is given to you second region में, that is the 2 epsilon naught. 2 epsilon naught. What is the electric field in the second region? ये पूछा है. Whereas the electric field to the left of the interface is given to me. कितना given है? 10ax plus 2ay, 10ax plus 2ay minus 10az. Minus 10az volt per meter. Now very important point is, what is a vector which is normal to the boundary? Everybody, what is a vector which is normal to the boundary? वो यहाँ पे आपको identify करना पड़ेगा. So this is the boundary. Okay, take a vector which is normal to the boundary, perpendicular to the boundary. That is known as a n cap, and that vector which is normal to the boundary is along the z. And usually we take the vector from the region 1 towards the region 2. Okay. So you will say whether it is plus z or minus z, both are normal. So from the first region to the second region. Okay. From the first region to the second region. ठीक है जी? अच्छा. अच्छा. Before I complete, इसी के साथ साथ एक point mind में याद आ रहा है. Before I complete, a surprise for you in the middle of the session. I told you that these days randomly I am giving you the password. So guys, the PDF of today's session and yesterday's session. Yesterday मैंने PDF share नहीं किया था. I told you yesterday only that first and second part combined होगा. The password for the PDF is going to be normal. Normal component पढ़ाया तो just randomly something clicked into my mind. Let's say the PDF is normal. All small without any space. Okay? That's going to be the PDF password. That will be shared to you tonight. The PDF will combine the today's class and the yesterday's class, both the classes content together. That you will get it tonight. Okay, the password will be normal. Okay, so passwords are only available in the live class. Okay, so an cap is equal to the az. Now what you have to do guys, always, okay, you have to break the given electric field. Whatever is the given electric field, the electric field can be broken into two components, Et and En, right? So electric field E1 can be E1T and E1N. The electric field E2 can be written as the E2T plus E2N. Okay. This can be written as the E2T plus E2N, right? Okay. Acha. What are the boundary conditions? What are the electrostatic boundary conditions that you must remember? Let me simply call it as boundary conditions. With respect to the electric field, the boundary conditions that you must remember is, sir, number one, ye lijiye. Number one, the tangential components of both the fields will always be equal. Number one, E1T is equal to the E2T, right? Number two, in the form of D field we write D1N minus D2N is equal to the rho s. D1N minus D2N is equal to rho s, where rho s is what? Rho s is the surface density at the interface, if there is some surface density. If not, then 0 ho jayega. D1N minus D2N equal to rho s, but D is epsilon E, so epsilon 1 E1N minus epsilon 2 E2N is equal to rho s, right? Right. PDF, Telegram pe, I'll share you the Telegram link also. Maybe थोड़ा सा आप पैनिक कर रहे हो मोनिका. Okay, just try to revise more and more formula through short notes. एक दिन का gap लो, revise all the formula, then appear in the mock test. Okay, so guys, these are the formulas to be applied. So first we should know what is the tangential component of the electric field. So now what is the normal direction? Normal direction is z ना, तो हम क्या करेंगे? If normal direction is z, this is known as the normal component, right? Remaining will be known as, anything perpendicular normal will be known as the tangential component. Okay, so what is the normal component? I will call it as minus 10 az. तो यहाँ पे ध्यान देना है आपको. My electric field E1 is, let me copy again, 10 to minus 10. 10 to minus 10. Acha. Out of which I am telling you, this is the normal component and this part is known as the tangential component. So what is the E1T? Sir, it is 10AX plus 2AY. So what is the E2T? According to the boundary condition, E2T is directly equal to the E1T. The tangential component is continuous across the boundary. So that is 10AX plus 2AY. No change in this. Okay. Then what is the E1N? That is known as the minus 10 AZ. So use the formula epsilon 1 E1N minus epsilon 2 E2N is equal to the rho s. What is epsilon 1? 4 epsilon naught. देखो वैल्यू सब गिवन है आपको. यहाँ पे 4 है और यहाँ पे 2 है. 4 epsilon naught into minus 10 minus, ठीक है, डायरेक्शन ठीक है बाद में आ जाएगा, minus epsilon 2, that is 2 epsilon naught E2N is equal to 10 raised to the power minus 9, that is the rho s. अच्छा, because rho s is in 10 power minus 9, तो epsilon naught की वैल्यू भी रख देंगे 4 into, देखो ये हो गया 4 into minus 10, that is minus 40 minus 2En minus 40 minus 2En into epsilon naught. What is the epsilon naught? 1 upon 36 pi into 10 की power minus 9 is equal to 10 की power minus 9. So 10 power minus 9 getting the cancelled, minus 40 minus 2En is equal to the 36 pi. So from here we can calculate the value of the En. Okay, E2N. From here, sir, what should be the value of E2N? Calculate करके आंसर बता देते हैं. कितना हो जाएगा? And that should be divided by the 2. So minus 76.5. Right, 76.5 minus 76.5. So what is the final electric field? देखो, what should be the final electric field? Electric field E2 should be E2T plus E2N, right? And what is the tangential component? That remains to be same. 10ax 2ay, and normal component is turning out to be minus 76.5. Normal direction means z direction, तो ये minus 76.5 az. Got the calculations, guys? So ये हो गया. The correct answer is 10, 2, 10 and 2, and this is minus 76.5. Option number C. Option number C. Simple. Simple. Divya says C. Yeah, I think only Divya got it correct. Some of you were telling A and B. That is not correct. Okay. All cool. Chalo. Okay. Yeah. Next question. But before that, those who want to know where the PDF will be shared, PDF will be in the Telegram group. So PDF will be in the Telegram group. Just a second. ये लीजिए. So PDF will be shared in this Telegram group. You can join this Telegram group to get the PDF and other updates about the classes. अच्छा जी. Going ahead to the next question, right? Going ahead to the next question. A current sheet J, 10 AY ampere per meter, okay, lies in the interface x equal to 0. ये थोड़ा सा यहाँ पे hidden है, तो मैं इसको ऊपर कर लेता हूँ. Okay, lies in the interface x equal to 0 between two dielectric media whose properties are given to us. Okay, if the magnetic field in region 1 is given to you, what is the magnetic field in the region 2? Okay, H1 is given, H2. That means magnetic boundary conditions. What we need to apply here is the magnetic boundary condition. अब पहले पूरा ये picture बना लेते हैं. Let us sketch the boundary here. What is the boundary here, guys? The boundary here is x equal to 0. Okay, this is the interface, this is the boundary. Okay, let me mention that this is the interface which is x equal to 0, which is x equal to 0, and that interface is carrying the current density of J, that is carrying the current density J. Kitna? How much is the current density? 10 Y ampere per meter. The sheet carries some current density. Okay. अच्छा जी. Now this vertical axis will be the x axis. ये भी बना लेते हैं यहाँ पे. Okay. This is x equal to 0. This interface is x equal to 0. So very clear that the above region is x greater than 0. That is x greater than 0, region number 1, and the region number 2 is x less than 0. The parameters are given to me for x less than 0 is the region number 1, x less than 0, and what is the epsilon की जरूरत नहीं पड़ेगी. Mu is equal to mu naught because mu r1 का value 1 है, and region 2 is x greater than 0 where mu r is 2. Okay, this is the region number 2 for x greater than 0, and mu is equal to 2 mu naught. Because only magnetic boundary condition is involved in this question, I don't want the epsilon value. Okay, so ये हो गया mu1, ये हो गया mu2. अच्छा जी, ठीक है. H1 is given to me. What is the H1 in this particular medium? H1 is given to me 3ax, ux या ax1 and the same thing, unit vector in the x direction, and 30 ay. Units are ampere per meter. Correct. So this is the H1 given to me. Oh, sorry. I'm sorry. I need to mention here. Actually, H2 निकालना है. This is the second region. H2 is to be calculated. H1 is given to me. That is the 3ax plus 30ay. Correct? 3ax plus 30ay. What is the H2? What is the H2? Okay. Now, what is the boundary condition with respect to the magnetic field? Let me write down the boundary condition formula here as well. What is the boundary condition to be applied? Number 1. Okay, so both the boundary conditions will be revised to you, the electrostatic and magnetic field also. Okay, the number 1 boundary condition is B1n is equal to B2n. But the question is given in the form of H, so what is B? B is mu H. So mu1 H1n is equal to the mu2 H2n. magnetic flux density normal component is continuous across the boundary. Second, H1T minus H2T cross, directly, sorry, let me write down the total field only. H1 minus H2 cross AN12, right, cross AN12 या simply AN बोलते हैं, is equal to the K. K is the interface current density. K is known as the interface current density. K बोल दीजिए या J बोल दीजिए, whatever you want to call it as, K or J. Okay, and AN unit vector normal to the boundary, and I told you from the region 1 to the region 2. So what is the unit vector normal to the boundary here, guys? What is the unit vector normal to the boundary? The unit vector, this is the boundary, this is the interface, and unit vector from first to second region, it is in the positive x direction. It is looking in the positive x direction. So this is AN, that is plus AX. That is plus AX. If the normal is the x direction, then what is this? This is known as the normal direction magnetic field, and then this is known as the tangential direction. The other one is the tangential direction, और ये है आपका magnetic field H1. This is known as the magnetic field H1. ठीक है? Everybody, this is complete. Okay, चलो. All cool. So let's move ahead to the boundary conditions. मैंने revise करा दिया. Let's use the data in the question. What is H1 given to me? Sir, it is the 3AX plus 30AY. Okay. Now out of the 3AX and 30AY, as we discussed, this is the normal component and this is the tangential. First, let us use the simple condition, normal component condition. Okay. Mu1 H1n should be the mu2 H2n. Mu1 is equal to mu naught, H1n is 3, is equal to mu2 which is 2 mu naught, and H2n, what is the H2n? ये निकल गया यहाँ से. So H2n is equal to 1.5. H2n 1.5. Okay, x direction में होगा. That means whatever is the answer, guys, it is going to contain 1.5 AX. Surprisingly, there is only one option. Question finished. No, I think यहाँ पे data error होगा. Okay, so that means it is only option number A. According to the given choices, as of now, it is option number A. Sometimes question can be finished. Okay, sometimes the question can be finished very easily. Okay, so yahi se, but I will complete this question for you. Right. Amrit, normal part, sikho, basically normal part, normal means what? Normal to the boundary. So boundary is x equal to 0. Okay, that is YZ plane. So what is the vector normal to the YZ plane? Is x. Whether it is plus x or minus x, so it should be from first to second. So according to the first to second, it is going along the positive x direction, Amrit. Okay, अच्छा जी, ठीक है. So basically answer is done. Correct answer is option number A. Okay, because only the normal component that is matching is 1.5 AX. Okay, ये देखो, ये H2n हुआ ना, ये केवल magnitude हुआ. So what is the vector form of H2n? The vector form of H2n will be 1.5 AX, and that is only option number A. यहाँ पे तो आप lucky हो कि ये हो गया. Here you are lucky that you got it, but not always correct, not always sufficient. तो हमें इसको आगे check करना पड़ेगा. So what we need to do now? Okay, so now what is the total field H2? The total field H2 should be H2T plus H2n, out of which I only know the H2n. Okay, that is in the x direction. Okay, यहाँ इसको reverse लिखते हैं. So that is H2n plus H2T, but I don't know what is the tangential component. If the option doesn't match, okay, only one option, maybe two options containing 1.5x, then I should know the full solution. So this is 1.5 AX plus tangential component will be other than x. Other than x matlab y or z. So it may be H2y AY plus H2z AZ. ये हमने assume कर लिया. Let's say this is the tangential component. How to find this tangential component? उसके लिए हमें क्या करना पड़ेगा? Now I am going to use the next boundary condition. H1 cross H2 cross AN is equal to the surface current. What is the H1? H1 तो total given है मुझे. H1 total is 3AX plus 30AY, right? Minus H2, that is 1.5 AX plus H2Y AY plus H2Z AZ. Okay. whole cross product with an हमने देखा ना, an x डायरेक्शन में है, an is along x डायरेक्शन, should be equal to j का वैल्यू है 10ay, should be equal to 10ay। अब देखो यहां से क्वेश्चन सॉल्व हो जाएगा। ओके देखो गाइस, what is the cross product of x with x? 0. What is the cross product of x with x? Is 0. Cross product between the vectors of same direction will be 0. Okay, so what is going to be left is 30y cross x. 30y cross x. Y cross x should be minus z. Okay, then ये हो गया फर्स्ट वाला, then minus ये वाला तो 0 हो गया, y cross x again minus z, तो minus h को ऐसे लिख लेते हैं इसको, h2y, y cross x is minus z plus h2z, z cross x is ay, should be 10ay। ओके, कंबाइन द डायरेक्शन, z to z कंपोनेंट कंबाइन करोगे तो दिस इज माइनस 30, यहां पे माइनस माइनस प्लस h2y az। ओके, माइनस को अंदर ले गए तो माइनस h2z ay should be 10ay। So very clear now how you are going to equate the two vectors। देखो ये क्लियर, यहां से क्लियर हो जाएगा, माइनस ऑफ h2z is 10, so what should be the h2z is minus 10। okay, from this component left hand side there is z component, right hand side there is no z component, that means left hand side का z component 0 होना चाहिए, minus 30 plus h2y should be equal to the z component of the right hand side, but that is 0। so यहां से आ गया, what is the h2y is 30, right? What is the h2y is 30, so what is the final h2? what is the entire magnetic field h2? 1.5 ax, यहां तक तो डिराइव हो गया था, 1.5 ax, we need to find the y and z component, y components are 30, z components are minus 10, so the answer is plus 30 ay minus 10 az, ये मेरा कंप्लीट आंसर हो गया। दिस इज हाउ वी अप्लाई द बाउंड्री कंडीशन। 1.5 30 minus 10, 1.5 and 30 and minus 10, sir already we have solved this। okay, तो क्वेश्चन वाज वेरी सॉल्व सिंपली ओनली बिकॉज ऑफ द नॉर्मल कंपोनेंट, बट अगर आगे करना पड़े तो हाउ टू सॉल्व द टेंजेंशियल कंपोनेंट, दैट आल्सो आई हैव टोल्ड यू, राइट? I have taken the cross in the tangential component on the LHS. Cross on the tangential component on the LHS. Cross in the tangential component in the LHS. LHS में ही तो cross है. I mean, what do you want to specify, Manish? Cross तो left hand side में है ना, H1 minus H2 cross AN. Anything else you want to say, Manish? Please specify. Please specify. Yes guys, so with this the important portions that I wanted to revise for electrostats and magnetostats with boundary conditions we have done. Okay, some basic Faraday's laws and displacement current terms also we have revised. Now we will move towards the core electronics part. Okay, but that we will plan in the next session only. Okay, so now the common part of ECEE getting over. Now we will have the session, that is the tomorrow EMFT part number 3 at the same time 6 p.m. okay, but now in one single part I cannot cover up the entire content. Okay, entire content in one single part cannot be possible. Now Manish, take it on the left hand side only, otherwise sometimes you may get the plus minus error. Okay, so EMFT part number 3 will be there tomorrow. So in one part EMFT entire electronics portion cannot be revised because we have plane waves, then we have transmission lines, waveguides and antenna. So one more part 4 will be coming, that will be on Friday probably. Okay, so one extra part, because yesterday we had to stop little early na, so because of that part 4 will be coming up. Friday ko part 4 hoga, but time of the part 4 I will tell you tomorrow only. Okay, but you know, in one part at least we are not able to cover the entire EC. So tomorrow we'll start with waves, transmission line as far as possible, then whatever is left, antenna hai, waveguide mein bhi dekhte jitna hota hai, whatever is left, part 4 we will create. Mostly Friday only. Okay, yeah, for by today ECEE common part is completed. For tomorrow, okay, tomorrow and part 4 only EC students have to attend, and mostly I will try to cover it on the Friday only, part 4, because Friday 9:15 I told you na, there will be MSQ class on the Hindi channel. right? MSQ class on the Hindi channel. Okay, so MSQ class of EMT only. So before we go to the MSQ class, I want to complete up the part 4 also. So I will try to keep the part 4 on the Friday only, right? Okay, so that you can attend the MSQ session, that is on the Friday, right, night 9:15 p.m. Okay, night 9:15 p.m. Acha guys, one more thing, PDF password already told to you, right? Kishan, basically I feel for gate inductors is not much important. That is why if you want, you can just revise the formulas whatever I have taught you in the earlier batches, right? Okay, and that too mostly if you are double E. EC wale hai, to you can skip the inductor part also, not much important. So guys, many students are still, because you are giving the mock test, listen to me carefully, because you are giving the mock test, so you may be finding difficult time management, and you may be in little bit doubt ki how you are actually going to manage the time in the actual gate exam day, right? So tomorrow Ashutosh Saxena sir in the same channel, tomorrow 11 p.m. or 11:15 p.m. let me check. Yes, that is going to be tomorrow 11 p.m. I think. That is going to be the tomorrow 11 p.m. I think. Yes, so tomorrow, that is Thursday 11 p.m. Ashutosh Saxena sir will be taking a session, okay, very effective session for the GATE 22 aspirants. How to plan your 3 hours of the GATE exam with the perfect time management tips. So Ashutosh sir will be taking the session. I have shared you the link. You can go set the reminder. You don't forget the session, okay? Set the reminder, do like the session, and tomorrow Ashutosh sir will be giving his tips. So I'm telling you that these months will bring up in very important things about the GATE exam. How to manage the time, how to use the virtual calculator, scribble pad क्या होता है, कैसे वहां पे use करोगे, all these things, every psychological factor also will try to cover before the GATE exam. So tomorrow 11 p.m. the same channel by Ashutosh sir, right? Chalo. Yes. Okay guys, so bye bye, thank you, stay safe, take care. Yeah, put the reminder on, that will be great.